All right. So for today, we are going to plot graphs. All right, we're going to go ahead and plot graphs for your activity. Did anyone attempt the activity last class?
Sir, I didn't.
Sir, I didn't send it in.
You did it and sent it. All right. Let me just look on it quickly. All right. So I see where 6 persons, right? I graded 2 of them. The 6 persons. I see Michaela, Rashawn. I got the chance to only grade 2 of them. Right. So this particular class will ensure that you have graph paper by the next class. All right. Can you get access to graph paper?
Sir, I'll try.
No, sir.
Yep,
No.
Eh?
sir. I'll try.
All right.
Yes, sir. Yes, sir.
So try and get access to graph paper by the next class. All right. So
Yes,
for
sir.
today, we're going to look on plotting graphs, right? Using simple pendulum data. And the graph that we want to go ahead and plot is length, right? Remember we discussed this, that as the length increase, we saw where there was an increase in the period, right? As it increased, we saw that there was an increase in the period, right? Are you hearing me?
Yes, sir.
Yeah, so as the length increased, there was an increase in the period. So when the length was increased from 42 to 45, there was an increase from 1.21 to 1.33. And this continued down to 1.58, right? Now, the important data that we want to pull out is the length and our period squared. Now, we take out this, the length will be on our x-axis
The period square will be on our y-axis.
and our period squared on the y-axis, right? So your graph should look something like this. Y-axis, and this is our x-axis. All right. Now, it's the same data we pulled out from this particular table here. The same data, length and period squared. So let's look on our graph now. We see that, look on our first point at 42 and 1.46. So we try and estimate the position of 42 and 1.46. So 42 would be around here, right? In this area between 40 and 45, right? Is that the case?
Yes, sir.
Yeah, so 42 would be around here. 43 would be here, right? And we have 44 here. So we have 41 would be somewhere here. 42 would be here, right? No, sorry. Let me try that again. Right? You would have 42 here, right? 42, 41 would be here. 43 would be somewhere here, and 44 would be somewhere here, right? It's not perfect. On your graph paper, it should be much easier because you would have the lines outlining this, right? But this is what I'm using now, right? It's not that easy to explain, right? So you have 42, and then on the y-axis we had 1.46, 1.46. So 42 and 1.46. What is in the middle of 1.4 and 1.6? What's in the middle here?
1.5, sir.
Yeah, so 1.5 would be here. So therefore 1.46 would be a little bit below, right? Somewhere here.
Good morning, sir.
All right, good morning. All right, so we have 1.5 in the middle of 1.4 and 1.6, right? So 1.46 would be in the middle of 1.4 and 1.5 would be here, right? So 1.46 would be somewhere here. All right, let me try one more. Let's try one more. Second point, we have 45 and we have 1.77, right? So 45 on our x-axis and 1.77 on our y-axis. 45 on our x-axis and 1.77 on our y-axis. No, what is in the middle of 1.8 and 1.6?
1.7, sir.
Right, so 1.7 is in the middle of 1.6 and 1.8. So therefore, 1.77, second here. 1.77 would be in the middle of 1.7 and 1.8, right? Is that so?
Sir, why don't it numbers, sir? Oh, sir, like, so we can see 1.7, like
That's what I'm doing now.
1.77. Write it down.
That's what I'm doing now, right? So it's an approximation. It's an approximation. So between 1.7 and 1.8, you'd have 1.77, right? Somewhere here. Are we all seeing that?
Yes, sir.
Right? Anyone not seeing that? Please let me know. Please stop me. Right? Although when we start the activity, I say, sir, I didn't understand anything in that class, right? Because another class did that to me. We went through this and everyone just turned and said they didn't understand anything when I gave them the activity. So please let me know if you're understanding this or not. All right. So we go to the third one. The third one is 50 and 1.93. 50 and 1.93. You would see something like 50 here and on the x-axis, and you would match this up to 1.93 on the y-axis. Now tell me what is in between 1.8 and 2.
1.9.
Right, so 1.9 would be here. So therefore 1.93 would be a little bit above 1.9, right?
1.9. Yes,
Yeah,
sir.
so it would be here. It would be somewhere here, right?
Yes, sir.
Are we all seeing that?
Yes.
Anyone disagree? All right, let's try another one. We have 55 and 2.2. All right, Jordan, I'm going to ask you to close the mic. Thank you.
The journey from Europe to the Caribbean and from the Caribbean to Africa.
All right, so we have 55 here and we have 2.2. So 55 would be on our x-axis and we would have 2.2 on our y-axis, right? So let's go to the graph. We have 55 here, right? 55 on our
50.
x-axis. We would match it up to this particular point, and we have what over this side? 2.2, right?
Yes, sir.
So you'd match these two values to make this particular point here. And we'll do this for the other points, right? So let's go back. We have the last point here. We have 60 and we have 2.5, right? So we see 60 here. On our x-axis, we have 60. So we match that up on our x-axis to this particular point, right? And then we have 2.5. Now tell me, what is in the middle of 2.4 and 2.6?
2.5.
Right, so we have 2.5 here, 2.5, right? And we would match this up to this particular point over here. Right? It's not a straight line, but we're getting,
Sir, 2.5.
yeah,
No, sir, 2.4.5, sir.
right? So the value is 660 and 2.5. All right, so we match this up on the particular graph. So when you're plotting a graph, you would find 2.5 and you would find 60 and you would make your point here. This would be your particular point. All right. Are we all understanding? Anyone not clear? We're good, right?
Yes, sir.
All right. One more confirmation. Are we good?
Yes, sir.
All right. So let me get rid of this. So now, after we have plotted our points, right, it is required of us to then get our best fit line, right? The best fit line is the best representation of the average of these points, right? So when you're plotting a graph, I don't want to see anything looking like this, right? That's not your best fit line. A best fit line is supposed to be a straight line, right? Not all the points will be connected to that particular line, but you want to get majority of the points as close to the line as possible or on the line, right? As best as possible. All right. So we plot our graph and now we have our best fit line looking something like this. Right. I'm not using a ruler, so you'll find that it's not really straight, but it should be as straight as possible and going through all or most of the points, right? Or as close to the points as possible. Now, if you realize these 2 points are approximately the same distance away from the line. Agreed?
No. No.
All right. Remember that I am not using a ruler. All right. So please be patient, right, with me. So let's try again. All right. I'm not using a ruler here. So you find that you have 3 points on the line, right? And these 2 points would be as close to the line as possible. All right, you see on the next slide. All right, so we can see now, the computer generated this, right? You can see now that these points are at the same distance away from the line, right? Or approximately the same distance. Agreed? Right? They're approximately the same distance away from the line, right? All right, so you want to have majority of the points or most of the points on the line, or you want to have them as close to the line as possible or at the same distances away from the line. This is the best representation, right? The best representation of your best fit line or the averages, right, of the points or the trend of these points. So are we all clear on a best fit line?
Yes, sir.
All right. Anyone not clear? Please let me know, right? Because I don't want to give you the activity, right? In the middle of the activity, you say, sir, I didn't understand anything in that class, right? Okay. And remember, you can interrupt me while I'm in the process of teaching. So we're going out to the equation of a line and we are moving, right? Our syllabus requires us to be able to calculate the gradient. But before we go to the gradient, we need to understand the equation of a line or at least be introduced to it. So every line that will come in contact with every graph, every linear graph that will come in contact, you will see that it follows this particular equation. or it is in this particular form, right? So we have our y as our dependent variable and our x as the independent variable. Now, what these mean, you have the x, let's do the x first. The x as our independent variable, right? This is unaffected. This is what we really change in our experiment, right? So this is what we alter. We alter the length and we see what happens to the period squared, right? So as we said, as our length increases from 42 to 45, we see an increase in our period, right? We see an increase in our period from 1.21 to 1.33, right? As we increase from 45 to 50, we see an increase of 1.33 to 1.39, right? So our length would be our independent variable because that's what we're changing, and our dependent variable would be our period squared. All right, you won't need to know the definition of independent and dependent variable now, but you just want to be familiar with it, or know, or to be able to identify which one is the independent variable and which one is the dependent variable. All right, so are we clear on that? We agree that our length is the independent and our period squared is the dependent variable. Are we all seeing that? Right?
Yes, sir.
Okay. So we now move on to the gradient. We have the gradient here and we have the y-intercept. The gradient and the y-intercept, and we go now and we'll try and explain these. So firstly, the y-intercept is the point at which the graph crosses or intercepts the y-axis. All right, so we'll show this now. Let's say this is our graph and we have our scale 1, 2, 3, 4. Now, where is our y-intercept? What is our y-intercept? This is our y-axis. This is our x-axis. What is our y-intercept? Let me repeat again. We have a graph and our scale is 0, 0, 1, 2, 3, 4. And we said that our y-intercept is the point at which the graph crosses or intercepts the y-axis. What in this case is our y-intercept?
0.
0 is 0 the point at which the graph crosses the y-axis?
2, sir.
2. So 2
Sir,
would be, right, so 2 would be our y-intercept, right? As
Yes,
that's the
sir.
point at which the graph crosses the y-axis. All right, so we have 3 minutes left. We will, let's touch on gradient, right? The gradient is the number that represents the steepness and direction of a specific graph. All right, so this should give you a better understanding. We have another graph here, and we have a line. We have 2 lines on this particular graph. We have line A and we have line B. Now, which one would have the higher gradient? Is it line A or line B? All right, let me repeat that. We have 2 lines. Somebody was answering?
Yes, sir. Line A.
Right, everyone agree?
yes, sir.
All right, so we have 2 lines and we said that the gradient represents the steepness and direction of a graph, right? And in this case, it is obvious that line A is much more steeper than line B, so therefore this would have a higher value for gradient. All right, so we are out of time, right, for now. Remember, we have class after lunch. So we will meet back here after lunch. All right. Any questions before we go?
No, sir.
No, sir.
All right. All the best, everyone. Remember to meet back early, right? We will only have 30 minutes after lunch. All right. All the
Yes,
best.
sir.
Okay.